Okay, we want to continue with our lesson, ending up chapter 3. And we want to do another couple of examples like we did in class of the two types of problems that we discussed. That first problem is going to be finding distance. And remember, that means perpendicular distance. Finding distance from a point P to a line L on the coordinate plane. All right, so let's see how we can do this. I'm going to plug this. There we go. I want to plug that in so that it didn't run low while we were in the middle of a problem. Okay, so we're going to take a problem that I found in the book, and it says that we have a line. So our line contains the point 1, 2, as well as the point 5, 4. And we want to know the distance from this line to the point 1, 7. Now, I want to just sketch out a little visual here so that we know exactly what we have and specifically what we're looking for. So let's make a little graph. It doesn't have to be fancy, but we need to get in our mind what we've got, what information we know. So we've got line L. I'm going to put my line in blue. So I've got points 1, 2. So 1, 2. And 5, 4. 1, 2, 3, 4, 5. 4 is going to be up here. And it only takes 2 points for me to determine a line. So I'm going to connect those. There's the line. And the point, I'll use red, 1, 7. 1, 2, 3, 4, 5, 6, 7. So my point is up here. Remember, the distance must be the perpendicular distance. So I'm looking for, how about we go in orange here. Maybe that'll be a better contrast. I'm looking for that orange distance. That's going to be the answer to this question. Okay, now that orange line, if I extend it, has to be perpendicular to my blue line. Okay, so we need to find the equation of that blue line L. Okay, so I'm finding L. I'm going to find my slope. The difference of the y's over the difference of the x's. So my slope is 1/2. Now I've got to use one of my points as a sample point, either 1, 2 or 5, 4. I'm going to use 1, 2 just because I have to pick one. So y equals mx plus b. I'm on the mission to find b now. When y is 2 and the slope is 1/2, x is 1. So 2 equals 1/2 plus b, or b is 1.5. So my equation for line y is y equals mx plus b. Now I need to find the equation for the orange line. All right, so my orange line, Let's see, we want the slope. We already know that if the slope of the blue line is 1/2 and the orange line is perpendicular to the blue line, then the slope of my orange line has to be, let's just call that line M. The slope of my orange line has to be the negative reciprocal slope of L. So -2 is the slope for line M. And we know the point on the line is 1, 7. So if y equals mx plus b when y is 7 and the slope is 2, x is 1. Add 2 to each side. My slope is, or rather my y-intercept is 9. So y equals -2x plus 9 is my orange line. Y equals -2x plus 9. Can you see that negative in there? Now, if I use those two equations for my system, if that's my system of equations, when I solve it, I'm going to find that point right there. And when I find that extra point, then I can use point P and the new point that I'm about to find, plug that in the distance formula, and I will know the distance I was supposed to find. Now I'm going to use elimination here, I think. And I'm going to multiply the top equation to get that 1/2 to be a +2. I'm going to multiply everything by 4. So this will become 4y equals 2x plus 6. I get rid of my fractions when I multiply through by the 4. And then y equals -2x plus 9. When I work that out, I'll have 5y equals 15, or y is 3. So that I know the y-coordinate of my new point is 3. That's called the ordinate, the y-coordinate. The y-coordinate, oops, there we go, has a fancy name of ordinate. Okay? Now, I'm going to find the x by taking the y and plugging it into one of my original equations. I'm going to plug it into that orange equation because that looks like easier arithmetic to me. So when I plug in, I'm going to have 3 equals -2x plus 9. Subtracting 9 from each side, I'm going to have -6 equals -2x, or x is 3. How about that? The point 3, 3. And if I eyeball it, I can kind of see if this had been on a real pretty graph, I could have seen that without having to do the system. But to be honest with you, I always do the system to make sure that my graph is okay. So we're ready for that final step. Don't want to do that. I want to do that final step of the distance formula. So we're going to use the distance formula. And I noticed last time we used the distance formula, a lot of you forgot to put squares on your quantities. So make sure that you put those squares in the formula. The two points we're going to use is we're going to use point P, and we're going to use our new point 3, 3. So let's plug in. Okay, I'm going to say 7 minus 3 squared plus 1 minus 3 squared, and that's going to equal to 4 squared plus -2 squared, which is going to be 16 plus 4, or the square root of 20. The square root of 20 in simplest form is 2 on the square root of 5, or as the approximate decimal value, it's going to be about 4.47. So those are your three acceptable answers. I prefer the last two, but some of your teachers here at Darlington prefer either the first or the last. Okay, so you'll just need to make sure you check each year with the teacher to see how they want you to handle a radical answer. So there's one more example like the first example we did. Okay, I think what I'll do is I'll make this one video, and then I'll put the example of the second kind in a second video, so that if you don't need to watch both, you won't have such a long video. Okay, so we can stop this one at about 11 minutes. That's really long enough for one problem. And then I'll attach a second video about finding the distance between two parallel lines.